Hi everyone. Let's see the last operation, which is operation number 5, reversal operation. Okay. So in reversal operation, we reverse the entire string present in the language. Let us say if a language contains A, W, B as a string, where W is nothing but it contains any number of length of string, and on the left hand side I will take A as the input, and on the right hand side I will take B as the input. So after reversing the language, the final string present in the language is B, W, A. So for achieving reversal operation in deterministic finite automata, you will take 3 steps here. So there are 3 steps which are required to convert a language into its reverse form. So the 3 steps are: first you have to make initial state into final state, so change initial state from into final state. The second step is change final state into initial state, and the last step is step number C, change direction of edges in the transition diagram. Change direction of edges in the transition diagram, but the loops remain as it is. So loops will not affect it, only the direction of edges will affect it. Okay, so let us take an example for understanding reversal operation. Let's say I have a language which have length exactly 2, and here the input alphabet is small a comma small b. So the string present in the language will be AA, AB, BA and BB. Okay, if I draw the transition diagram, then the transition diagram contain capital A as the initial state, and here A, B, I will go to the next state capital B, and again take A, B and go to the final state capital C. Okay, and on final state, if I see one more A or B, then I will go to the dead state. That means I will simply reject the string. So capital D is the dead state. So this is the transition diagram for the language which have length exactly 2. Now if I reverse this language, so reversing this language means L power R will be AA will not affect it, but AB will change to BA change to AB, and BB remain as it is. Okay, and in the transition diagram what you will do here is you will make initial state as a final state. So initial state is capital A, which is final state, and capital B will remain as it is. Finally make final state as a initial state, so it is initial state. Okay, and let's say D here, and change the direction. So here the direction is from A to B, then I will change the direction from B to A, which is A comma B, and here also the direction is from B to C. I will change the direction from C to B, A comma B. Okay, and here the direction is C to D. I will change it from D to C, A comma B. Okay, so this is the final transition diagram for the reversal language. Here you will not notice the difference so much. So take another example, because the language itself is very small. Let's take another example. Let's say I have a language L, where string starts with A. String starts with A. Starts with A. So what are the possible strings? The possible string will be A, AB, ABA, AAB, and so on. That means it is a final language. Infinite language. Okay. In infinite language, if you draw the transition diagram, the transition diagram will contain capital A as the initial state, and then if you see A, you will go to the final state, capital B, and on capital B you will accept any number of A's or B's, and if you see small b on the initial state, then you will reject the string. That means you will go to the dead state. Let's say dead state is capital C, and here any number of A's or B's does not affect the language. Okay, now if I reverse the language, then the strings in the language will change to, let's say here it does not affect it. AB will change to BA, ABA will change to ABA, AAB will change to BAA, and so on. Okay, and what about the transition diagram? The transition diagram will be, the transition diagram for this language will be, make initial state as final state, final state as initial state, and other states will remain as it is. Change the direction. Here the direction is from A to B. I will change the direction from B to A, and here also change the direction from C to A. So it is B, and the loops will remain as it is. Okay, here also loops will remain as it is. So this is the final transition diagram. Okay, so I think you understand the process of converting deterministic finite automata into its reversal form. Okay, so that's all about the operation on deterministic finite automata. In the next video we will see a new concept in theory of automata.